Welcome to a lesson with Dr. Powell. Let's take a look at how we can compute the derivative of this with using a limit. This is just a practice problem, and I have lots of practice problems on this, but here's just another one with y prime, and we're going to be using a limit. Okay, just some key things, common errors, mistakes when people look at this is they say, okay, if they use x plus h, sometimes people say, okay, I'm plugging, they don't know necessarily what to do with the x plus h. Sometimes people think like x squared minus 2x plus 3 plus h. Sometimes they plug something into x, and there's all kinds of things that can happen, but let's try to think about really what's happening. Just focus on what's going on. You're finding the slope between 2 points. You can use h or you can use a. There's two different ways of approaching this, and I'll talk about each one. So we have 2 points. One of the points we're plugging, so for one point we can just plug in, say we plug in x for one of the points. What's the output, the y value? Well, it's just sitting right there. Let's make some more room for it. Let's okay, so it's just, this is the when we have x, we have that point. So we're looking at 2 points. We're looking at 2 points on our curve. Here is 1 point. Now another point is we're going to go a little distance away from x. We represent that by saying x plus h. This h could be a positive or negative number a little away from x. Then what do we do with this? What's the y value at that point? You plug x plus h into the variable x, all right? So that would be x plus h quantity squared minus 2 quantity x plus h plus 3. So we have a point and another point. All right, so then what we're looking for is we're looking for rise over run. Okay, so we take this minus that. Okay, so this y value minus that y value, x plus h quantity squared minus 2 x plus h plus 3, and then we subtract off this, and I'll put this in parentheses so I can remember I'm subtracting off this whole thing, x squared minus 2x plus 3, and then put that all over. Now what's the run? Just this minus this, which just happens to be h, right? It should make sense. X plus h minus x, which is h does represent the run, the distance that we've moved with x here, either positive or negative, which is fine. Okay, so this would be one thing, and then we're taking a limit of this, right? We're taking the limit as what? The run h goes to 0. All right, now the computation of this limit we can work through, and that will give you the derivative. Notice that in this limit computation, x is actually not the variable of the limit. H is the variable of the limit. X is treated as a constant within this limit. H is the thing that is changing. Now, as I multiply through, we will get some cancellation. You may prefer the A method, which I'll show in a minute, because in that method we actually we don't have as many things to expand as we go along to see the cancellations. Okay, but let's just do that here. What's x plus h quantity squared? I'll write it right above. X squared plus 2xh plus h squared. As a way of thinking about that, the middle term is just 2 times that times that. This term is just that times that, and this guy is just the first times the first. Okay, at least with this square. All right. Another common mistake, algebra mistake people make is, even in calculus sometimes, is x plus h squared is equal to x squared plus h squared. I don't know if we're forgetting something or what, but please never do that. Think of this as being x plus h times x plus h, and there's some distributing to do. All right, so we end up getting that. Just a little side note, make sure that as we practice this, we avoid some common errors. Okay, so thinking about that. All right, so we got that right there. And then this part distributes, so negative 2x, and then negative 2 distributes to h, negative 2h. You have a plus 3. The negative will distribute to each part there. Negative x squared plus 2x, and then minus 3 as the negative distributes through. All right, now look at the top here. X squared and x squared, they cancel. Also, this negative 2x and that 2x cancels. This 3 and that negative 3 cancels. It cancels in such a way that we have h is a common factor on the top. So we can factor out an h on the top, which is great, because then with the cancellation, we'll get rid of our domain issue of plugging in 0 for h. So we end up getting as a 2x plus h minus 2. You can check that this, if you multiply this out, gives you these three terms here. 2xh comes from 2xh, h squared comes from h squared, negative 2h comes from negative 2h. Perfect. And then we're taking a limit still here. All right, those h's will cancel, and then now we can plug in 0. And when we plug in 0 for h, notice we get in the limit 2x minus 2. Okay, so that is how we can compute the derivative using the h method. Let's compare this to what it would be if we're using the a method. Okay, so the a method is similar to what we just did, except the points we pick are a little, we name them differently, but it's really equivalent to what we're doing. I mean, instead of letting our two x values being x and x plus h, we just let them be x and a, where x is kind of a fixed point, but a is heading in and getting close to x. So we could think of this as one point as being a comma and x comma, and then this is pretty simple. Just plug a in for x. It's a squared minus 2a plus 3. This one, okay, well, we're pretending like we haven't computed 2x minus 2 yet. Okay, so we're looking at y, right, as our function here. Now if we plug in x here, we just get x squared minus 2x plus 3. So rise is just this minus this. Notice, so you can even just, you just subtract. Okay, so a minus x is a minus x. That's the run. That's in the denominator. Okay, now it's this minus this. Notice the subtraction, the 3's cancel. So we're left with a squared minus 2a minus x squared plus 2x. Notice I distributed the negative through to this when I subtracted it off. Negative x squared plus 2x. So, and then we're taking a limit of this fraction as a approaches x, as those 2 points get close together. That's equivalent to saying the run's going to 0, h going to 0, or a going to x. They're two equivalent ways of thinking about it. Okay, so we end up getting, right, so we end up getting a squared, and I'll put a squared minus 2a minus x squared plus 2x all over a minus x. Now, I'm going to separate this into two different parts. You see this a squared and x squared? Let's put those guys together. All right, so we can think of this as being like a squared minus x squared, and put the negative 2a and the 2x together. So minus 2a plus 2x. And why I'm going to do that? Because I'm going to unadd fractions, like distribute the division, like distributing multiplication, distributing division, because this division really is like multiplication by a reciprocal, right? Division is multiplication by a reciprocal. As you divide by 2, it's like multiplying by a half. Oh, but multiplication distributes over like subtraction and addition. Like we're in unadding fractions. So take a look at this. So we can like put an a over, we can do something like this, right? And I'll just leave that negative right there and just make a plus right there. Notice this would work. If we're adding these two fractions, what would happen? You just, because they have the same denominator, want to go back to that. Just make sure that that looks right there. Now, why would we do this? This actually makes it fairly simple. Because in here, take a look. Don't we know how to factor this a squared minus x squared? That's like a minus x, a plus x all over a minus x. Cancellation. Oh my goodness, I can take the limit of this one little part because then I can just plug in a is heading toward x. Remember, a is the variable and x is the constant. So a is set a equal to x, and what would we get? X plus that's 2x, right? This one part is 2x. This limits to 2x. Hey, that's that part right there. Hey, this other part better limit to -2, and it will if we look at it. If you factor out a -2 on the top, it's just factoring at this point, we end up having a and then minus x. You can double check when you distribute this -2 and you get -2a, and that becomes a plus 2x. Awesome. But don't you see cancellation? You get a -2 in that limit. Oh, well, that's exactly what we wanted, which was this part. So the A method is actually kind of nice sometimes. I mean, it depends on preference and what you're used to or want to do or makes sense to you or whatever. I mean, the one thing that you might get to this step and say, I don't know what to do. But hopefully this video helps you kind of understand what you can do. The parts that have, that are similar, group them together like that. I mean, it's kind of like this. I actually just use the A method per term, like do it for that term, then do it for this term. Then if you want to do it for this term, you can, which actually tended to cancel out completely because it canceled out right here, really, and so it's just kind of blue. But really, you could do it for each part and then just add the results together. That would be fine. Okay, and that's kind of what we mimicked when we separated it that way. Okay, well, that gives you a little practice problem with something. I mean, we didn't address ones like with the square root or a 1 over or something, but I have those in other videos. You can take a look at this. This video was mainly here just for trying to discuss common errors and things to watch out for as you work through such problems. Thanks for watching.